In the last video, we looked at a Python program that searched a list using the sequential search algorithm, also known as the linear search algorithm. And today we're going to look at a different method to search a list. Now, as usual, I'm going to start by going to the schedule, and we're currently in the fall 2017 semester. Let's have a look at the schedule for the course. And if you scroll down to week 11 here, we're now focused on searching. Now, this link will take you to a PowerPoint presentation on the topic, and the same presentation is shown as a PDF in this link, so I'm going to, for convenience, use this link, be a little bit quicker. So click on the searching link and it takes you to the PDF on the topic of searching. So again, I'm going to just talk about Python searching. Now, in the last movie I introduced the topic of searching, and we looked at the linear search, which is also known as the sequential search. We had a look at an animation for that search, and we looked at a Python 3 program that implemented that animation. So now we're going to look at the binary search algorithm, and excuse me, this is at screen 19, so if you want to just jump down to screen 19, you'll see the binary search algorithm. Now, the binary search is a more specialized algorithm than the sequential search that we saw in the last movie, as it takes advantage of the fact that the data has already been sorted. Now, in the sequential search, it wasn't necessary to sort the list, but the binary search relies on the fact that the data has been sorted. Now, it is a much more efficient search. It doesn't take as many steps to find an item in a list. So, how does it work? Well, the basic idea is to divide the list into two halves. So the first thing we have to do is find the midpoint of the list and then examine the data at that point. So how does it work? So here we've got a list. Now notice this list of integers is in sorted order. It's in numerical order. Lower numbers going up to higher numbers on the right. Now, this binary search algorithm works by finding a middle point of the list. So you're going to find the length of the list, divide it by 2 to give you the midpoint. Now, if you've got an odd number of items, you can choose which item you want to be as the midpoint. It's not really all that important. But here we've got a list. Now this list has got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 elements. So the midpoint is right here. You've got 8 elements on either side. So we could take as the middle item this on the left or this on the right. It doesn't really matter. So since the data is sorted, when we're looking for an item, we can compare the number we're looking for. Say, for example, we're looking for number 11. Then if we compare 11 to one of the middle items, whichever one we chose, if 11 is on the left-hand side, if it's less than 33, then we can ignore all the data greater than 33 on the right-hand side. If we're looking for the number 88, we know that it's on the right-hand side because it's greater than 35. So, let's have a look. So, since the data is sorted, we can immediately ignore one half or the other of the list, depending on where the value we're looking for lies in comparison to the value at the middle. Now, this means it's a much more efficient search than the linear search. We can eliminate in each step half of the list. So a binary search algorithm involves breaking the problem down into a smaller version of itself. The list is split in two parts. repeatedly. Now, because of this idea of breaking the problem down into smaller version of itself, this is a great candidate for a technique known as recursion. Now, recursion is an advanced topic, and you will certainly learn about recursion if you go on to do a data structures course in computer science. But for now, we don't really need to worry too much about recursion. So I'm going to skip over the screens for recursion. So let's have a look. So binary search involves binary decisions. So we're having a decision with two choices. Now we're either going to be looking at the data on the left of the list or on the right of the list. So you're eliminating half of the data that you're searching. So say for example you've got a list of 16 numbers, we can say n is 16. You can find any number in that list in at most 4 steps. So your original list is 16 in length. You're going to divide it by 2, so it's 8 in length. And you divide by 2, become 4, become 2, become 1. So here we've got 4 steps in order to go through the entire list when we're searching a sorted list for any number in that list. Now if we take log to base 2 of 16, this is 4. So this is a log base 2 16, which is 4. So we're looking at log base 2 of any number of elements in a list. So if your list is 16, it takes at most 4 steps to find any element in the list, if it's in the list, or maybe only 4 steps to find that it is not in the list. So searching, for example, for the number 7 in this list, first of all we split the list into 2 halves. We decide on which is going to be the midpoint. In this case, I'm taking number 33. So we ask a question, is the number we're looking for, is it less than or equal to 33? Well, we know it's less than 33, so we can ignore all of the items on the right hand side. We're only interested in this half of the list. So the next step is to divide the new list, this is our new list, into 2, and we're going to compare the number that we're looking for, number 7, to the item at the middle of the list. So here we're using number 10 as the split point item, and we ask the question, is 7 less than or equal to 10? Well, it's less than 10, so we can eliminate all of these items to the right. And so all of these items now have been totally, we don't need to search in that. We know we need to search only on the left hand side of this midpoint. So we split the list in 2, and here we've got a new midpoint value, and we say is 7 less than or equal to 7? Well, this is true, so we found the number 7. So it took us 3 steps in order to find the number 7 in this list of 16 elements. Now, if you've got a list of 10, then if we take log base 2 of 10, our value will be 4. If our list is 50, then log base 2 of 50 will give us a number 6. So this is the maximum number of steps needed in order to find any number in a list of 10 or a list of 50 numbers or a list of 100. Notice if you've got 10,000 values in your list, if your list is of size 10,000, at most you will only need 14 steps in order to find or not find the item, the number from that list. So in general, a binary search operates on one of 2 data structures. In general, the binary search is operated on a list, which we've been looking at on this course. And there is also the tree data structure, and we're not going to be using trees in this course. We focus on lists. So there is an animation here that shows you how the binary search algorithm works. So let's have a look at the animation. And thank you to Daniel Liang for providing this animation. So this is a binary search animation, and here is our sorted list. Now this list has got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 elements. So we've got 16 elements. How many steps does it take to find a number in this list? Well, let's for example look for number 94. So let's change the key to 94. That's what we're looking for. This is the number to look for, 94. So remember, the first step is to divide the list by 2, find the midpoint. So here we found the midpoint, and we're going to compare the number that we're looking for, 94, to that midpoint. Now because 94 is greater than 56, we're going to be looking in the right hand side. So now we can eliminate, we don't need to look in the left hand side, we're only interested in searching in the right hand side. So our list has been divided by 2. So that's the first step. The next step is to divide the new list by 2 to find the midpoint, and there it is. So here we've got a new midpoint, and in this case we're going to compare the number to find with the new value at the midpoint. And because 94 is greater than 88, we continue looking on the right hand side. Excuse me. So the next step is to divide the new list by 2. And here, once we've divided this new list by 2, the middle item is actually the number we're looking for, number 94. And you can see there that the key is found at index 13. This is index 13. And we've found our value. So how many steps did it take? 2, 3 steps at most. This took 3 steps for a list of 16 items. The first step was to compare with the original middle of the list, and then we had a new list compared to the middle of the new list, and then we split the list again and found the key after 3 steps. So let's find a new value. Let's reset this. Here we can see you can reset with a random list. Notice the list is always in numerical order, and it is possible that the same number occurs 2 times, but in this case they're all unique numbers. And let's look for the number this time. Let's try looking for number 97. Now if this was a linear search, we'd have to start at the beginning and go through each item in turn, and it would take us 16 steps in order to find number 97. But with a binary search, it's going to take fewer steps. So let's take the first step. We take the middle point of the list. Now because 97 is greater than the value at the midpoint, we're going to be looking on the right hand side. So our new list is this list. The next step is to divide the new list by 2 to find the new middle item. And here we've got the new middle item. We compare this number, the key 97 is greater than 90, so we're going to look on the right hand side. So this is our new list. We're going to divide the new list by 2 and make the comparison here. Now because 97 is greater than 94, we've got a new list, and we'll step again, and we know that the item is going to be at the next midpoint, which is at the number 97. So now we found, after 5 steps, number 97 in our list. Now this took 5 steps with a binary search. If this was a linear search, it would take 16 steps. So the binary search is much more efficient for lists which are long lists. If you have a very short list, then the sequential search or the linear search might actually take fewer steps than the binary search. But with a long list, when we're talking about big data, the binary search is much more efficient. So it becomes much more efficient as the number of items in the list grows. So there is our animation, and thank you again to Daniel for providing this animation. And if you go back to the searching algorithms PDF, you can see the binary search is starting at screen 19. and I'd recommend you just review this and look at the animation to get a good understanding of the binary search algorithm. And at that point I'll finish this movie.